We already made the final exam for this semester. I already forgot the details. I already gave to the secretary. She already printed out all the copies, and but should be very similar format. And we're gonna have like a most of problems 12 points for each. And there was 2 bonus problems. Bonus problems 8 points for each. You should do all of them as much as possible. Okay. The only difference bonus problem was the other problem is that when we grade the bonus problems, we don't give too much partial credits if it's wrong. Okay. So 8 points, maybe either 4 or 0 or 8. It's not like, oh, I can't give 2 points, 3 points. It's bonus problem. Okay. When you prepare for the final exam, you may also have to have like write down something on the notebook, summary of some ideas for certain type of problems. Okay, but at least they should go through all those 5 sample final exams if possible. There's lots of exercise, very similar to each other. They're trying to do it at home. Now, I'm not going to post a solution for you. I don't think it's a good idea. Okay, we don't scientific research show that there's no bigger difference. Like one class students that gave the final exam, example final exam was a solutions. Another class without solutions. We don't see difference. Sometimes the students without solutions will do better. Okay, because why? Because you just look. Okay, I cannot look at the solution, and you thought you understand, but because you did not work harder to figure out the solution. Okay, but then the next question: how do I know my solution is correct or wrong? Well, at this point, you shouldn't know the solution is correct or wrong. Even if you don't know whether the solution is correct or wrong, that really don't understand the problem. Okay, so maybe the answer is wrong, but the idea you shouldn't know this 100% is right. You have to tell me like that, right? Otherwise, if you're not sure, it means don't count this problem you can solve it. You probably still don't know how to solve it. Okay. So that's not necessary for the solutions. I still remember when my brother got into college, he was a few years behind me. He was always trying to ask me, brother, can you find a solution menu for the textbook somewhere? I said, don't do that. It's a stupid idea. Solution menu. Yes, there are some books published solution menu for textbook. I told him, no, don't buy solution menus. You have to work out the problems by yourself. Very few problems you really have a trouble, to solve. Okay. First thing you have to do is don't go to Mac. Okay. Even I know you encourage you to go to Mac. If you have a time, you look at textbook that corresponding section, or look at the notes for that section to see if I already discussed this problem you're trying to understand. Then come back to solve it. If you solve it, you will memorize it. The same problem, exactly the same problem on the test, we can do it. If you immediately turn to, tutor in the Mac, yes, he or she show you how to do it, and you are not able to do it again if I put exactly the same problem on the test. Okay, so this is my suggestion. As long as you have time and you work out the rest of the final exams, you can find your classmates together, compare the solutions with each other. I know there's some group of students that they're close to each other very well. There you can communicate, check the answers, and if you believe your answer is correct, your classmate's answer is wrong, you explain to her. Okay, when you explain your ideas, help other students. Actually, you also get benefits because when you explain to them, you actually memorize the idea more than before. So you'll be not nervous when doing the test, less nervous because you already explained the problem to the students. Okay, so helping other people is also you get benefits from that. Of course, you may get help from a couple problems from the tutor, But if you get help from the tutor, you mark the problem. And before the final exam, you look at the problem, cover the solution. Are you able to solve those problems? Yes, then it's okay. Otherwise, you see, no, it's not a good idea, right? To get help direct immediately from people, okay, from a tutor, okay. I'm going to final exam. I'm going to work on the first sample final exam, okay. I'm not sure I can able to finish all the problems. I'll do my best. Then next review class, I probably will focus on few type of problems, but you can also send me questions. Okay, like for example, can I, you can ask me, like problem 3 on sample 3. Can I discuss in the classroom or not? And I will do that. I look at that, and so if I have to get emails from you first. Okay, you can ask me during the class time too. Okay. Well, the first problem is about the limit, right? So limit is the first part of a calculus one. Okay. So if you see a limit like that, x squared minus 2x minus 3, x minus 2, you cannot just plug a 2 for x to get a limit, because it's going to be 0 over 0 type maybe, right? In this particular case, if you plug a 2 for x, you will, you don't know, right? You cannot, the numerator is a number, the denominator is 0, so you cannot solve the problem quickly. But what you can do is, you should figure out what is the limit of the numerator. The numerator, you can plug a 2. If you cannot simplify, sometimes you can simplify, okay? Cancel x minus 2. But in this particular case, you are not able to simplify, okay? You cannot get rid of x minus 2. So when you plug 2 for x, you get 2 squared minus 2 times 2 minus 3, which is negative 3. But the numerator, as a denominator, x approaches 2 from positive side. So x minus 2 is positive, but getting close to 0, so you put a positive sign. Okay? So negative 3, and the denominator is positive, but getting close to 0. So this gives you the limit negative infinity, right? So you get the answer right away. Okay? You may try to factor the numerator, but you are not able to solve it. Okay, you're not able to cancel x minus 2. There's no factor of x minus 2 in the numerator. So well, as long as you are able to get, like, if it's negative and the plus, then it will be negative infinity, right? If it has negative plus, and this from the positive side, this will be positive infinity. Okay? So the 0 has no sign, but 0 negative means it approaches here from a negative side. So the value will be negative, but it's getting close to 0. Okay? But if the numerator is positive, then the ratio will be negative, then it approaches negative infinity. Okay? There are some problems you have to simplify first, okay? Using algebra. Again, you cannot just plug 0 for x into the denominator and numerator. The numerator becomes 0, the denominator also becomes 0. It's a 0 over 0 type. So it's a 0 over 0 type. You cannot tell the limit right away. So you have to try to do some simplification. So let's do this. X minus 2, x squared minus 4 is 2 squared. Okay. Let me rewrite again. Okay, combine them, it's going to be x squared, 2 squared, 2 squared minus x squared, and x minus 2. So since it's 0 over 0 type, so I'm pretty sure the numerator, there's a factor of x minus 2 there. So it's 2 minus x, 2 plus x. So x minus 2 can be cancelled out. The numerator, the value 0 and x equals 2, that means it contains a factor of x minus 2. Okay, so x minus 2, 2 minus x cancelled out, but then you get a negative sign. So it'll be negative 2 plus x and the 2 square x squared. Then you get the limit quickly. It's going to be 2 plus 2, 2 square and a 2 square. Okay, so the numerator is 4, the denominator is 16, so the answer will be 1 negative quarter. Okay, so this is a limit as x approaches 2. Simplify the expression before you plug the number for x to get limit. Right. Now you will always to use a limit definition. I use a definition to find the limit. Right. So if the function is going to be square root x plus 1, and you have to find the derivative. But the derivative is a limit as x approaches a. Here's x minus a, and f of x minus f of a. Okay. So in other words, just need to find the limit. Right? You cannot use any other method to find the derivative, but you can use a formula you learned later to find the derivative of the function. Okay. And so you can check the answers. I know the derivative will be 2 square a plus will be this. Right? If we use a formula to find the derivative, right? But we have to use a limit to find the derivative. So x minus square fa, and here's x minus a, right? It's going to be square root of x plus a minus it's plus 1, and the a plus 1. Here's x minus a. To find the limit as x approaches a, you cannot just plug a for x into the numerator and denominator, because you are going to get 0 over 0. Very similar to the above one. You have to try to get a factor of x minus a from the numerator. You cancel the x minus a. So the typical method is you multiply the similar expression by changing the sign. Then the numerator is going to be x plus 1 minus a plus 1. All right, and you should be able to get x minus a in the numerator. Yes, and this will be x minus a, but x minus a canceled out, and then after you simplify, you get an expression like that. Now you can find the limit easily. Just plug a for x. When x approaches a, and this will be a plus 1 here, square a plus 1. And that's the reason why it's twice of square root a plus 1. Okay, so that is the derivative of the function. So when you see radicals, that's a very standard method. Okay, simplify the expression. Yeah, simplifying the expression is very important. For example, if you have a cosine 2 theta, right? Find the derivative of this. You may use a quotient rule to find the derivative right away, right? but still have to deal with the cosine 2 theta. What is the derivative of cosine 2 theta? Now, can you simplify it? If you start to simplify, then maybe it makes it much easier, right? So how do you simplify? Cosine 2 theta is going to be cosine square theta minus sine square theta. Right? So it's a square minus b square. So you will get cosine theta plus sine theta, and the cosine theta plus minus sine theta. Right? So immediately those two cancel out. This complicated function turns out to be just cosine theta minus sine theta. Okay? You see that, right? So the derivative is easy now. Easy to find out. It's again negative sine theta minus cosine theta. Then if you don't want to simplify the function, you get a very complicated expression after you find the derivative, and it looks very ugly. Okay, and maybe you lose some points. I don't know, because it's not simplified version. Yeah, you can use a quotient rule to find it, right? What you get is, if you don't want to simplify, you will get like a sine theta plus cosine theta square, right? Then the numerator is negative sine 2 theta and times the denominator, and minus the numerator times the denominator. So it's cosine theta minus sine theta. Then you what? Then you try to simplify it. Okay, it's not easy. So just leave it like that. Give it to me, right? Okay. Yes.
The last one that you just said, it's like it's the final answer of this.
No, that's not the final. It looks very ugly. Sometimes we will take the points off. Okay, it's not simplifying the version at all. Okay, and compare with my answer like this. So simple, all right? We always have to simplify the expression. And the cosine theta minus sine theta is very simple. Now look at this. You never imagine this will be simplified too. It's cosine theta minus sine theta. Okay. All right, so always remember, before you give a function, before you find the derivative, look at the function. Don't just apply the product rule, quotient rule directly to it. Okay, immediately. Okay, you have to look at the function. Are you able to simplify or rewrite the function in different form, so you can easily use those simple formulas to find the derivative. Okay, otherwise it's just more complicated. It's easy to make mistakes. And something like that, for example, this one, right? Find the derivative. Okay, then say, okay, this is a product of functions. I have to use product, right? But you can avoid using product. Okay? How? Because 1 plus x squared can multiply this out, right? That's one step. Then you multiply this out. It's 2 x squared x plus times x is x squared over 2, and x 1/2 plus 2 is 5 over 2. Okay, so the sum of power functions, then you differentiate term by term. That will be very simple now. Plus 3x to the 1/2 plus 5 over 2 x to the 3 over 2. Okay, so then this is what I want to get. Now, if you use a product rule, well, it's not too bad. If you use a product rule, what do you get? The derivative of square x. I hope you remember this. And plus the derivative of 1 plus x squared will be twice 1 plus x. Looks fine, right? Yeah. Now, how do you simplify it? So probably no way to simplify. You can take 1 plus x out. Okay. Yeah, you can take 1 plus x out. You get this. Is this simplified version? Not yet. So you can take 2 square x out minus 4x. Finally, I get this. Okay. Let's double check. Our computation looks like quite different from the previous, right? That's minus, it's plus. That's why I make mistakes. It's a 5 here. Yeah, it's plus. Okay. So this is the answer. Okay. So there are different ways. When I grade the test, you know, I probably see different type of answers. Like this one is a product. If you multiply this out, you will get same answer as above. Okay. The next problem is x and y are related by this equation. Okay, find the dy of dx. So x and y, 2 variables, they are related by this equation. But we are able to stick. We're trying to find the derivative. So what you do is you differentiate both sides by x squared with respect to x. Okay. So x is a function of x. Y squared is a function of x. So you apply the product to this problem. So you get 1 y squared plus x, derivative y squared be 2y, and dy dx. And here again you apply the product rule. So dy of dx sine x plus y. So derivative of sine x with respect to x will be cosine x, and minus 0. Okay, derivative 1 is 0. Right, so then you mark those containing x. Then you move them together. So 2xy minus sine x dy dx equals y cosine x minus y squared. And then you solve for dy dx. All right. All right, so the next problem, you let f of x, let f of x to be x to the 4/3 minus 4x to the 1/3. Find the critical numbers. Now, by definition, critical number is a number which the derivative doesn't exist. So before you find the derivative, right, you look at which numbers the derivative doesn't exist. I think critical numbers x equals 0 is a critical number. So immediately you have to mention that x equals 0. Because when x equals 0, the second from x to the 1/3 is not defined as derivative. Yeah. This just because this does not exist. Right? So critical numbers, not the numbers at which the derivative is 0. The derivative is not, does not exist also is critical numbers. All right, so we assume x is not equal to 0. When differentiate, you get 4 over 3x to the 1/3 minus 4 over 3x to the 1/3 minus what? It's 2 over 6. And clearly, this is not going to be defined when x equals 0. But x could be negative, could be positive. So you set this to be 0. Question, how do you solve it? Well, you have a constant, the same constant, right? You get rid of it. So how do you simplify this equation? How to simplify this equation? You multiply by x to the 2 over 3 every term. So the first term is x, second term is going to be x to the 0. That's a 0. So x is going to be 1. So what is the critical number? So the answer will be 2 critical numbers. But this problem was on the test. We noted that about 1/3 of students did not pay attention to the 0. Okay. Critical numbers, x equals 0 and x equals 1. There are 2 critical numbers. Okay. So don't forget the numbers which are not the derivative doesn't exist. So when you do the when you're given a problem, first of all you have to record the definition of critical numbers. Okay, not just because of derivative. You use the usual way is just find the derivative. If it's 0, then you get critical numbers. But sometimes the derivative doesn't exist. You should also count those points. All right. The second one is sketch the graph for this function. Find the local maximum, local minimum points and points in fraction. Sketch the graph. All right, so sketch the graph. You needed to know when x equals 0, right? What is the y value? Y value is -1/2. Then when y is 0, x is going to be -1. So those are 2 special points, intersection points. All right, so this is -1. So graph passes those 2 points. Okay. And asymptotes, the first one is x equals 2. Right? X equals 2. And x equals 1 also is a asymptote, which is horizontal, because the limit as x approaches plus minus infinity is going to be 1. Yeah. All right. So that's the reason y equals 1 is a asymptote. All right. And I think we are almost there. So nearby x equals 2, y equals x plus 1, x minus 2. It's about over x minus 2. Because when x is close to 1, 2, x plus 1 is 3. So about the asymptotic behavior of the function, it is determined by this function, 3 over x minus 2. So and for equation like that, here's 2. This is the y equals 3 over x minus 2. So our graph should be similar to that, nearby the vertical asymptote, right? And when x approaches 2, this is the approximate point. And clearly, right, you can draw the graph like that. I'm pretty sure this. What I want to make sure is the curve is does not go across the horizontal asymptote. Yeah, you can also look at x plus 1 over x minus 2, whether it's going to be 1 or not. Okay, so you will get x plus 1, x minus 2 minus 1, it's x minus 2, it's 3. Okay, so this will be never be 0. So those two curves do not go across the horizontal asymptote. I think we already sketched graph even before we started derivative, right? Concave down, concave up, decreasing, also decreasing. So my claim is I can look at the graph, it's always negative. Okay, no question, it's always decreasing. And here, this will be negative if x is negative, and x is less than 1 or negative. And the second derivative is positive if x is greater than 1. When x equals 1, that's a trouble. Okay, so one can come up, other one can come down. And you can double check that. Okay, when you differentiate, you will see this. But just sketch graph, there's no need to find the second derivative. Okay, unless there is a local maximum point, local minimum point, then you have to find the exact location of this maximum point. Then you find a derivative to get critical numbers. Then you get to the local maximum point or local minimum point. Okay, so you are not. I'm not going to find the derivative to verify this, but this is a typical example without using derivatives, taking sketching graph. The next one is if 1,200 pi square centimeters of the material is available to make a circular cylinder. Circular, yeah, with an open top. Find the dimension, find the largest possible value, yeah. All right. Okay, so step 1, draw the graph. And this is the cylinder, right? So you have this cylinder. What's the bottom and what's the top? Find the dimension. Like largest positive value. So this is a radius. Here's h. Right? And fixed. What is a fixed? The surface area is fixed, not the volume. Remember, last problem is the volume is fixed. You want to find a dimension that minimize the surface area. Right now, the surface area is fixed. You want to find the dimensions. Actually, and you can find it. Yeah, you find the dimension such that this cylinder has a max, has maximum volume. So given some material, right? This is also a very good problem. Given material, what kind of a cylinder you can make so that you can hold as much possible water as possible, right? Yeah, you in the real life you always do the lots of calculation, mathematical calculation. Unfortunately, many people don't do the calculation. Okay, and so that there's a big difference. Even you can have a choice. You know, you invest the money. Someday you make some money. You know, someday, okay, not right now, enough. And then you have multiple options to invest. Okay, then you have to do calculation. Don't just make a simple decision, and that will later on will really make a bigger difference. Because like here, you see, company, cylindrical type of tanks, right? You do some simple calculations, and you decide, okay, what is the cheapest tank you can make, right? Or use the same material, how big a tank, cylindrical tank you can make, okay? And sometimes a tiny bit of difference make your company either bankrupt or increase. Right? Grew up, right? So write down the material is fixed. So the surface area, how to calculate? It's going to be the bottom part, okay, and the side, okay, right? Pi r squared plus 2 pi rh. That is going to be 1,200 cubic meters. Okay, we want to find the volume. Volume is going to be pi r squared times h. We want to find the maximum value of this. Okay, how to do that, right? There's two variables here, h and r, the dimension. But h and r relative. That cannot be arbitrary. The surface area is fixed. So how do we solve this problem? I think that from this simple relationship, we should solve for r first, h first. Okay, h is easier, right? So r squared plus 2rh is going to be 1,200. So h is going to be, right? Otherwise, you have to solve quadratic equation. So you solve for h. And put it here. Then you get a volume as the volume function in terms of r. Cool. It's a v. Because another problem is talking about the area, surface area of a given volume. Now here we are given the surface area. We want to find okay, pi r squared 2r 1,200 minus r squared. Okay, and then you cancel r, you get pi over 2 here, r times. Now this is a polynomial of degree 3. But when r is sufficiently small, the volume is going to be very small. That means you make a very long cylinder, just like a tube, right? Then you can make it sufficiently small, then h should be very large. You can, but then the volume, Yeah, the volume is getting small. Okay, so if you want to find the relationship between the volume and the R, when I is 0, volume is 0. Okay, when I increases, when I is going to be square root of 1,200, volume is also 0. So it looks like that. Somewhere you have maximal volume. Okay, somewhere you have maximal. Right, so we differentiate. When you differentiate, you have to multiply this out. It's like RQ, right? So the derivative is going to be pi over 2, 1,200, right, minus 3R squared. And you set this to be 0. Then you get, say, R squared is 1,300 divided by 3 is going to be 400. So I is going to be 20 centimeters. Okay. When I equals 20, then the volume has maximum value. Okay, volume has maximum value. Okay, the volume is going to be the maximum. Okay, you can use the last formula for the volume. Okay, you will get pi over 2, 20, 1,200 minus 20 square. 20 square is going to be 400. Okay, you multiply this out, you get an answer. Okay, that's cube centimeter. So I know that the number of students feel much harder to solve story problems. Yeah, there are many reasons to do that because in before calculus, there's not enough word problems we call it, right? So it's difficult to set up the function. See, if I give you the function already, like a v is going to be pi over 2 times this polynomial degree 3, you know how to find it. The critical numbers, how to find max value. But the question is how to get that. Okay? You have to draw the picture most of the time. Then it involves 2 variables. There are not many problems we can put on the test. We always use this, cone-like cylinder, right? Remember, right? And this is a circular cylinder, cone-like, cone-like tank. Okay, circular cylinder, cylindrical tank. Okay. All right, so now there are a bunch of integral problems. Usually we have 3 to 4 integral problems. You have to use the substitutions to evaluate. Okay. The very first problem, we want to know the definition of the integral. Okay, definition of the integral is going to be the limit of the Riemann sums. Okay, so limit of the Riemann sums, and this is means delta xi, they all approach 0, and here's b, and the delta xi is going to be x I minus xi minus 1, and this xi star is in the interval, is the arbitrary point in the interval. Now, Riemann says that, okay, Riemann says that you don't need to consider those general Riemann sums. Okay, if f of x is continuous, then you can calculate this integral using special Riemann sums. Okay. And how special? Delta x is just equal to b minus a over n, and xi is just a plus I delta x. Okay. So you don't need to consider very general partition. And the xi is very specific, it's not arbitrary. So the function like this, we are not going to ask you to evaluate, right? We just want you to express this as limit of the Riemann sums. And then I think it's obvious because here delta x is going to be 1 over n, and the xi is going to be I over n, right? The I delta. So this can be a limit as n approaches infinity. F of xi, what is f of x? This is going to be like I n cubed 1 plus I over n squared, and delta x is 1 over n. That's it. You don't need to do simplification, elimination, all of that. This can be as limit. So for sufficient large n, that number is very close to the value of the integral. Then you can use a computer to estimate. You can use the estimate. Just to take it. Computer can do completely quickly, like the derivative multiplication, given the square root of this, right? So all you have to do is just let n. You can write a proof very short, like 3-4 lines if you use the main proof. Yeah, all you have to do is just enter the function, enter the value of n. Within a second, you get the answer. Then you say, well, why have to start that? Because there's a computer there, you know. A couple of reasons you have to start. Number one is for small reason. Maybe someday you have to design software, and you can say, oops, then you have to study it. It's too late, okay? You have to learn lots of things here, there, and a little bit. Maybe you can still remember things like that and go back to find it. Find the book, find the source. Otherwise, you cannot even read it by yourself later on if you need it. Another reason is doing those problems to training your brain. Brain is a biological organ, right? If you don't train them, it cannot think. Okay, so if you do well in mathematics, then you can do well in other subject. You know, if you do well in physics, you also can do well in mathematics, and vice versa. Okay. Okay. So if some financial institutions are trying to hire people, then they're open. You know, they say anyone can apply for the job, and then everything is similar. But if the guy look at you're young, I'm just scoring mathematics much better, and you probably have a much better chance to be hired. Okay, like Citibank, those things. Okay, evaluate this integral. Evaluate this integral. When you're given this integral, sometimes I would say, well, the reason I put 2 here is I still give you a chance to multiply them out to value integers. If I put 100, I force you to use substitution to evaluate integral. So that was, I put this problem last time, for fun exam. I was thinking about maybe, this square, a little bit more complicated, but if you don't want to use substitution, you're still able to solve it. Okay, so there are a couple ways to solve this problem. If you don't want to use a substitution, you will get like this 1 plus 2u squared u to the 4th power. Then continue multiply this out. It's going to be 12u cubed, 6u to the 5th, right? Then you find the antiderivative of each of them will be 3u squared, and that will be 3u to the 4th power, and that will be u to the 6th. Not too bad, okay? You know, you can quickly write all the antiderivative of the functions. You double check when you differentiate in ds, you get the stuff. And from 0 to 1, and then plus 0 for u, everything 0, just 1. So 3 plus 3 plus 1, not too bad, 7, right? Right. That's called direct method. We use a substitution, maybe that's a much quick way. Substitution is you let w to be 1 plus u squared. So dw is going to be 2u du, okay? So the integral becomes when u is 0, w is 1. When u is 1, w is 2, okay? And then that's w squared. 6u du. Okay, it's 3 dw. Cool. That's 3 dw. And the entire derivative of that will be w to the 4th cube, right? Because when you differentiate, it gets 3w squared. So it's 1, 2. So that's going to be 2 cube minus 1 cube. Again, this is going to be 7, right? It's interesting. Yeah, so it's 7. Completely different integrals end up with the same answer. That's always the magic mathematics, you know. We they never get contradicted as long as your computation is correct. Okay. Evaluate the indefinite integral of this. So mathematics is different from biology. You know, everybody believes that right now the DNA looks like a skeleton, right? I'm not sure. Have you seen a picture like that or not? Yeah, I was trying to look at textbook because only the drawing, no real picture. Maybe some, yeah, maybe it's possible. Yeah, otherwise you don't see it. It's still hard to believe it. Okay, just assume, you know, you assume that it's true. Okay. Okay, how do we evaluate this integral? This is a quotient of the two functions. Definitely there will be this type of problem. Quotient. Maybe you have to use substitution first. Maybe solve the problem, right? Okay. So in this case, there's no quotient rule for the integrals. So you have to express that as a sum of power functions. Okay. So that's the only way you can do. Okay, you square it. It's 1 plus 2 square x and x. So the first term will be 1 over square x. Second term is just 2. The third term is square x. Then express them as a power function. So x to the negative 1/2, 2. The antiderivative of that function. Okay. Finally, get 2x to the 1/2, 2x, and a 2 over 3, x to the 3 over 2 plus constant. This is good. Now there's a possibility, and there's a possibility you have to evaluate something like that, and that is going to be x plus 3 squared dx. Question, I'll give you 2 minutes. Because a problem like that will be one problem. 8 points can get up to it right. Okay. Let's see. Yeah, in order to express it as a power function, sum of power function, then this should be a single variable, so power. But right now it's expression. The first thing you have to do is to use substitution. Okay, you let u to be x plus 1, then it's okay. Then you get square u. And what is x? X is u minus 1 plus 3, right? And dx just du. Very similar. Okay, so it's going to be square u here, u square minus 2 square, no, just not u square, just u. Okay, du. Then you get u square plus 4u plus 4 du. Okay, then you multiply this, then you express it like u 2 minus 1/2 is 3 over 2, and 4 u to the 1/2, 4 u to the negative 1/2 plus du. Then you find the entire derivative of each term. Yeah, then you solve the problem. Just one more step actually for this problem, and then you convert it to a familiar expressions. So that would be the entire, let me just write down the entire derivative. Okay, it's going to be 2 over 5 u to the 5 over 2 plus 8 over 3 u to the 3 over 2. Yeah, plus 2u to the 1/2. Okay, no, I should get more than that. It's 8. Yeah, plus 6. Okay, because 8 times 1/2 is going to be 4. Double check, right? So finally, you get u is x plus 1, right? Just so you replace by x plus 1. Okay. The next one is about to sketch the region and find the area. Remember, area is going to be the integral of the length. Okay, so the region R is bounded by these two curves. Okay, and you have to sketch the region and find the area. Okay, so first of all, you sketch the graph y equals 4 minus x squared. It goes like that. Okay, right, and then continue going on, right? So this is plus minus 2. When x equals 0, that's 4. X minus 2 will be, when x equals 0, will be negative 2 here. So the graph, when x, yeah, the graph passing through this point. So that is the region. Okay, so region is bounded by those two curves. Right. Now our key formula for the area is going to be integral of I use a t here, alpha to the beta. So if you have a region like that, what you do is you draw the line, a reference line t, and you draw a family of a line perpendicular to that. Okay, and you measure the length. Okay, measure the length of this cross section, and length times dt, ln t times dt gives you the area of this strip. Okay, So the area of this strip is going to be LAT dt, right? And then integrate, add them together, you get total area. So for this particular problem, the axis will be the x-axis, okay? But I have to find the intersection point. And this is clear, it's going to be 2 and 0. How about the other one? So 4 minus x squared equals x minus 2. So x squared plus x, and move forward to the left-hand side, it's going to be 0, right? So x plus 3, x minus 2 equals 0, okay? So x equals -3, x equals 2, x equals 2 is clear. But x equals -3, the y value is going to be -5, okay? All right, so what are you going to do? I'm going to project the whole region to the x-axis. This is going to be -3 here. So I draw those lines here. Okay. And for each x, for each point x, you get the ln x. So the area is going to be integral from -3 to +2 ln x dx. And what is ln x? It's the difference of two y values. The one on the top is this parabola, right? The one at the bottom is x minus 2. Okay. So for the fixed x, you get the y coordinates of the top point, the y coordinates of the bottom. Then you get the ln x. But don't forget, there's a dx here. Yeah, that's dx. It's there. You cannot delete it. All right. So I'm not going to waste time to evaluate this integral. This is everybody knows how to evaluate this integral. Okay. The next problem is to set up the integral for the volume obtained by rotating the region. Okay, this is a region x equals y squared and x equals 1. The rotation is about the y axis. Okay, set up an integral for the volume. For the volume of the solid, you're going to get. You have to draw the graph. You have to draw the graph. X equals y squared looks like that. X equals 1 looks like that. Okay, this is a region. So very first step, you have to draw the draw the region. And you're going to rotate this region about the axis, about the y-axis. So that's the picture, right? And so the base, if without specifying the method you have to use, you have to decide which method you use, right? You can use the discs, you can use a cylinder to solve the problem. If you use the discs, I'm going to set up a integral, okay? If you use the discs, and then you get disc, right? Each time. So this is a point when that's when negative, right? So the area is going to be integral as a volume, not the area. It's going to be the area times dy. Area depends on y variable, right? Y starts from -1 to +1. Okay? The area is a cross section. All right, so the area is a cross section. area's cross section is going to be pi r squared minus pi little r squared. Right? Capital R is a fixed. So capital R, the little r depends on the point. If you use the x, y variable for that point, so capital R is going to 1. This little r is going to be x. But you're going to have an integral with respect to y variable. So it's going to be y squared. Okay? So this will be pi 1 squared minus pi y squared n squared. Then the volume is going to be this. But if you want to use this, if you want to use cylindrical shears to solve the problem, okay, how do you do that? Well, you have to use a cylinder to cut it, right? What you got is a cylinder here inside. Okay, this is a radius r, this is a h. So you have to have volume is going to be integral a r d r. Okay, I start from 0 to 1, not from negative. What is AR? AR is the surface area of the cylinder. Inside it's going to be 2 pi r squared. No, not 2 pi. 2 pi r times h. Okay. But then just need to find express h in terms of r. That's easy, right? Express h in terms of r. If this is r, what is h? Right? What is h? This is a point x and y. So I is going to be x, h is going to be 2y, right? Double. But h, you know, x is going to be y squared. So y should be square root of x. If you still use the variable r, then h is going to be, yeah, you can use the x variable, x, right? If you use the x variable, this is x, h is a square root of x and the dx. Okay, because y equals square root of x, you put it here, so it's going to be 2 square root of x. That gives the h. This is the h part, this is the r part. Okay. So two different methods give you two different. So on the final exam, maybe you will be asked to set up two integrals for the volume, okay, using two different methods. You're not just give you one option, you have to give them two. Okay, like a problem, typical problem like that. Okay, and it's not very complicated. You can figure it out, but you have to draw the graph clearly. Then you can figure out the formula for the integral, yeah, for the volume. Okay, so let's stop here.